Scientific notation is a way to write numbers using powers of 10. So we are used to writing numbers in standard form. Standard form is the way we usually write things, but that doesn't always work. If you have a really, really large number or a really, really small number, scientific notation generally is easier. So just a quick recap from past days, because I'm sure this is not the first time you've heard of scientific notation, but it might be the first time in a long time you've actually used it. So recall that scientific notation is a number times 10 to another number. Keys being this number must be between 1 and 10. If it is less than 1, we call that small. If a number is greater than 10, we call that big. Okay, that's kind of a side piece here. So if you have a number that is small, which is less than 1, then this will be a negative exponent. If you have a number that is large, then this number will be positive, and it will be, because we have a big number. But all in all, you're always changing your number so that your front number is between 1 and 10. That is our goal. Okay, now that I've thoroughly confused you, let's actually get into a little bit of a problem and see what this looks like. So we have a standard form problem here, 325,700,000, which is the approximate population of the U.S., and we're going to change this to scientific notation. Okay, now this number is greater than 10. We call that big. So we are going to have a positive exponent. All right, this is just kind of your thought process on the side. I need my front number to be between 1 and 10, so I want my decimal point to be right there, 3.257. All non-zero numbers must come along for the ride. Recall, in a number, if you do not see the decimal point, it comes at the end. So what I want to do is I want to move it from that blue dot to that red line. And that's going to tell us the value of our exponent. So 1, 2, 3, 4, 5, 6, 7, 8. It took me 8 positions to get there, so my exponent is 8. It's positive because this is a large number bigger than 10. I usually feel like, I talk about money. If you would be okay with somebody handing you $325 million, it's a positive exponent. 7.3 billion. Okay, this gets into our number sense with powers of 10. So recall from a previous video that billion means 9. So I could take my front number, 7.3, and then billion simply means times 10 to the 9th. Well, 7.3 is already between 1 and 10, so the approximate current world population of 7.3 billion, there it is in scientific notation. Now, unfortunately, not everything is that easy. So the distance of the Earth from the Sun in miles is 92.96 million. We know that million means 6. So I can take my 92.96 times 10 to the 6th. However, 92 is bigger than 10. Greater than 10 means positive exponent. So I need to change this to be scientific notation. I'm going to move it one place over. So this is the same as 9.296 times 10 to the 1st because I moved it one place. But remember, I already have times 10 to the 6th. 1 plus 6 is 7. So my final answer is 9.296 times 10 to the 7th. Because they're both positive, so they go together. Again, that's not always how it works. So now I have 0.86 million. Approximate population of Indianapolis. Remember that million again means 6. But when you look at this front number, this is less than 1. That's small, so we have a negative exponent. So if I change this, I got to move it to be between 1 and 10. I only moved it one place, but my exponent is negative because 0.86 is small, right? It's less than 1. But I already have times 10 to the 6th. So my final answer is 8.6 times 10 to the 5th because negative 1 plus 6 equals 5. That's how I got the exponent of 5. What is all of that? Okay, so now we're converting to standard notation. meaning I have scientific notation. I want to go back to where I came from. So I have 6.789 times 10 to the fifth. Now this fifth is positive. Positive means big number. So I want to move my decimal 5 places in the direction that will get me a big number. So 1, 2, 3, 4, 5. I put zeros in my empty humps, and I've got 678,900. Again, I would be okay if somebody handed me that much in cash, and therefore positive exponent. Same idea, positive exponent of 3, we're moving our decimal 3 places, should be after the 6, so 3,456.78. You're still allowed to have a decimal in your answer, right? That's fine. You just have to put it in the right spot. Now let's do some math. Multiplying with scientific notation. Basically, it's got 2 steps and then an evaluation piece. First is we're going to multiply the non-powers of 10 together. So 5.92 times 6.3 gives me 37.296. Okay, now right there you should say, that's not in scientific notation, but we'll get to that in a minute. Then I take my powers of 10, 10 to the 9th times 10 to the 5th. You may or may not recall your powers of your exponent rules from high school, but when you multiply with the same base of 10, you add your exponents. So 9 plus 5 gives me 14. So this answer is roughly 37.296 times 10 to the 14th power. But as I mentioned earlier, 37 is greater than 10, which is big. Therefore, we want to move it 1 place, and this becomes 3.7296 times 10 to the 1st. Well, 10 to the 1st and 10 to the 14th yield 10 to the 15th. So 3.7296 times 10 to the 15th. Again, think about it. When you're multiplying these, same base, you're going to add the exponents, and that's how we get 15. Last one is a division problem. Whatever comes first goes on top. So sometimes it's easier to rewrite them vertically. We first start by dividing our pieces. 1.9 divided by 4.62 yields 0.411, and I rounded that. Now, when you're dividing with the same base, you subtract your exponents. So now I'm going to take 13 minus 4, which yields 9. Now this is an okay answer, except my front number is less than 1, which means it is small, yielding a negative exponent. So if I move it 1 place, that's 4.11 times 10 to the negative 1st. That has to be negative because this is a small number. Now, negative 1 plus 9, right, because doing that, we end up with 4.11 times 10 to the 8th as our final answer.